a simple concept, but it is the basis for other programs like the BFS you're going to learn, A star you're going to learn. Anywhere when maybe you're using the algorithm. But the primary concept is you need to find the next cell. So a, when you're moving from one place to the another place, robot is moving from the one place to the other place. But everything, the total maze should be divided into the cells. Okay, cells like what we have discussed in the earlier case, right? So you can see uh, this is a maze, right? You can see everything is divided into the rows and columns. And so this is again a matrix or a maze where everything is divided into the rows and columns. So whenever if I want to move from here to somewhere here, then how, if you can move diagonally also you can move, or if you need to move from the vertical and horizontal lines, if you want to move from here to this place to this place, then how you should move from here to here, then you have here to here, like that. Or if you can diagonally pass the grid, okay, then you can you can go like this, and you can go like this, right? So this is how you will be moving from one place to the another place while you are using the robot. The problem is many times how we divide the total surface into the larger cells or a minimal cell, that we have to select, that we have to choose. Based on that, we will go through. So last, anyway, just I'll repeat the what we discussed about this example in the function. We were discussing about the function. So basic function, we have discussed many things like gripping, an example, and another examples also. So while in the Python, though we are learning the Python, we're parallelly learning the implementation of the things with the Python. So here, generally, we were talking about a functions, examples of the functions, right? So in that we have taken we want to design a function which is named as is path clear. Okay, it's a simple tool to check if a straight line is clear of obstacles. Are there any obstacles or no obstacles? Okay, so how do I get there? That is a question. So normally function logic is the code checks for any, for here the mainly we whatever we have written in the example as we are in the starting early days, because we are trying for an example of the function, we have only written to check for only for horizontal or vertical paths, whether any path, there is no path means if any obstacle is there, there is no path. If there is no obstacle is there, then path is there, right? So function logic is same. Then path blocked is if the obstacle 0 is found, okay, the function uh, immediately stops and returns false. So something is in between, then we can say it is 0, or 0 means there is something is there. So there is no path. So false is remit. So if true always is there, that means there is a path. So how do we check? So from starting to the ending location, okay. So if there is always true, then there is a path. So here limitation is it cannot handle the diagonal paths, diagonal paths, and will incorrectly report them as clear. Okay, before only we are telling that. Then we are using the grid data structure. As I said, we'll use the list of rows and column. Okay, so the outer list contains the rows and each inner list is a row. Okay, so we can represent that with the grid of y x, where y is the row and x is the column, right? So you can see y is the every y element Okay. So is considered as rows. These are the rows. Okay. These are the columns. So that's what we discussed in the previous session. So here we are writing a clear cut path, right? If what we are doing, the arguments we are taking the grid and starting point and ending point. So you can see, say we want starting location is 2.0. So where is the 2.0? Okay, so this is the 2.0, right? If you are saying 2.0 means x and y coordinate, x values 2, y values 0. So this is the 2.0. From here we are checking to 2.2. There is no obstacles, right? Because there are no in between blue colors. So 2.0 to 2.2. Or if you want to go with the 2.2 to 2.4, 2.0 to 2.4, then there is an obstacle, right? So we'll see how the code we are writing. So for that, we have taken this grid, okay? So in terms of the list of lists, then start xy and end start y, end x and end y. Here, what it will do, it will check if the direct path in a simple grid is clear or not. Okay. So so it returns the boolean whether if it returns the path is clear, that means true. Okay. If it returns a false, there is no path is clear, there is an obstacle in between. Okay. So the simple code is this. Okay. So let me execute this. So what we are doing here, let me once again before execution, I'll explain. So first we'll taking the start x is equal to end x. Okay. If it is true, okay, then the path, the what is the path for y in range we will check. Okay. From starting to the ending, we'll check whether any obstacle is there. Okay. Otherwise, we'll go with the another. So you can see here, one way we'll go with the horizontal line and one way we'll go with the vertical line. So if we are taking this example, okay, uh, one. So if you're taking the example, if here start location is 2.0 and end location is 2.2. Here x values are common. That means what? The path is vertical. And we need to increase the y values from minimum value to the maximum value. And we need to check any zero is there in that particular location or not. So how they're taking the data? So they're taking the data like this. Okay, so here this is the y index, this is the x index, right? Right? If something is obstacle, it is considered at 0. So what is this position? Grid of 1 comma 1 is the position, right? Because it is in the first position, and uh, if from starting if from here we're getting, this is also, if your 0 starts from here and 0 starts from here, it is 0, 1, 2, 3 and 4. If 0 starts from here, 0, 1, 2, 3, or normally in a clear. Okay. So, so anyways, we'll be solving the uh, two issues like we're only allowing the candidates from the tomorrow only who have given us the declaration form. Okay. So then we'll also directly can communicate with you. Directly we can talk with you, and only have to. Most of you need to understand that we're starting. So what that's what we do. First, we'll if the x values are equal, we'll check the y in range. So we'll start from the minimum start y and end y, uh, and max of start y and end y. We'll check this range. Okay. So let us have an example uh, of the code, and we'll start doing this. So here, the first, how do we have, what we have to do? We have to define the code. Okay, for simplifying the thing, I'll just copy this, uh, what we call this point, so that whenever we see there in that screen, we can easily understand by seeing over there, right? On- So this is our what we call important notes, so that we can understand, and we'll also take the grid. Okay, grid representing the code. Okay, so we'll also take the grid. Okay, so this is the grid. So grid is this, where wherever there is an obstacle, we're considering it as zero. Wherever there is no obstacle, we are considering it as uh, hash. Okay, so okay, we get the comments somewhere. Yeah, starting comments or not. Okay, so here, so this is the grid, right? So that's what we are taking. So here, wherever there is no nothing is there, it is considered as one. So if x is equal to zero, y is equal to zero, this is considered as one if there is no zero, right? So here you can see that example, that diagram. If this is the place, x value is zero, y value is one, right? So this is what this is the null value, right? Null, that means nothing is there, so we can consider it as one. If something is there, we consider it as one. So how do we write this grid? Say, how do we write this grid? How do we prepare it? Simply, simply, if you want to write a grid of, grid is equal to, okay, then we'll write in terms of the list, right? So we'll write zero, a grid of 0, 0, 0, comma 0. Is already some green color is there, so we can consider it as 0, right? And grid of 1, comma then what is this position? X is equal to 1 and y is equal to 0, right? 1, comma 0 is equal to again 0, right? And grid of 2, comma 0. 2 is the x value, y value is 0. 2, comma 0 is equal to nothing is there, right? It is considered as 1, right? So then it is 3.0 is also 1, okay? And 4.0 is also 1 because nothing is there. 3.0 is 1 and 4.0 is 1 because nothing is there. And 5.0 is 1 because nothing is there. So that's how we are preparing. So here, uh, these are the x values. Okay, these are the y values, right? So y value is 0, x value is anything, right? So in that case, what will the row value? 0, 0. What will be the y0 row value? It is considered as 0, 0, 1, 1, 1, 1, right? So that is the list. That's how this list is prepared. Okay, fine. If there is some obstacle is there, it is considered as 0. And if nothing is there, it is considered as 1. Okay, like that we'll be preparing total list. So this is one list, and this is one list, and this is another list. This is another list. Okay, right? So normally if you write like this, then there may be confusion in the x in the place of y in the place of that we can transpose, right? That we can use the transpose option for that. Anyways, so here like that we are creating the grid based on the actual figure. This figure is not related to this values, so that is different figure, but the concept is same. So here what we are doing to find an obstacle first, whenever some starting point is given and ending point is given, what we have to do, the function is to check whether any obstacle is there or not. How it has to check? From starting point to the ending point, it has to check every location. So somewhere 0 is there. That means then it should say that false, right? Because it won't directly work on the diagram. It work on the data only, right? First, it will check start x and end x. Then it will go with the range. Once start x and end x is there, then it will find the minimum of start y and end y, and maximum of start y and end y. In that way, it will go with the range. So here in the example, here start x and end x are same. So what is the minimum of y and minimum of y, minimum of start x and uh, start x and start y and end y? Okay, and max of start y and end y. What is the minimum of start y and end y, and what is the max of start y and end y? So minimum of start y is this. So maximum of start y and end y is this, right? So if we check, so what is the minimum of uh, in this scenario? So this is the start location, this is the end location. So we know that start x is equal to 2, start x is equal to 2, and end x is equal to 2. So both are same. First is okay. First constraint is uh, satisfying. Then we have it will go and check in the for loop. How it is checking? It is checking with the for loop for y in range. So what it is doing? It is checking range in between two values. What are those values? Min of what is the min of y? Min of y is max of y is equal to 2.
Just a minute.
So
I will-
from these two values, if you want to find the minimum, if you want to find the minimum of these two values, you'll write the min function, right? Min function will be writing. So in this, what we'll get? This will result in 0, right? And then we need to find the max of y, max of this y, right? So, so how we'll find? Min means it will specify as the start location. Max means it will specify the end location, right? So max is, you have to understand that, because while we are the robot has to move from one place to the another place. You have to give it the locations, xy locations, right? What is the xy locations in anywhere? Xy locations are whenever you are starting a grid or your screen resolution also. In the screen resolution also, everything is considered in terms of the x and y locations, right? So if you are going to the left corner of your top corner of your screen, it is considered as 0 0, or in the right down corner if you go, it is considered as some max value of x and y in your resolution, your screen resolution. So everywhere whatever surface you consider while you're moving from one place to the another, it is divided into the X and Y grid. It is divided into the X and Y grid, right? So whenever you're dividing everything in the X and Y grid, so it will be like this. Okay. So say I'll create a new screen. So say you want to divide a surface into rows and columns. Okay. So this is the starting look start. So this is the 5 into 5 location. So 5 into the total surface is divided into the 5 into 5 locations, right? So this is when you are talking about the X and Y, if you're considering it as X and Y positions, if you're considering that with the X and Y positions, normally you can see a graph, right? When you see any graph with X and Y, okay? In the same manner, you can consider that in terms of the grid, okay? So normally when you say an X and Y graph, okay, this will be the X, right? This will be the Y. But if you're considering in terms of the surface, this can you can consider it as X and this you can consider it as Y. But whatever way maybe you're considering the X coordinates and Y coordinates. So these index positions, based on the index positions only, you will be working. So everywhere, any surface will be considered in terms of the X and Y coordinates, right? Even if you're using a screen, the left top corner, so you'll be given at the resolution, right? Resolution means or if anyone is having the paint, you can see when you're moving your cursor on the screen, the resolution will appear in the right down corner. The X and coordinates or X and Y coordinates moves, right? In the same manner, if the even if the robot also want to move from one location to the from here, say from this dot, okay, from this position, if it wants to move from this location, okay, from here to here, then from here, what is the X and values, X and Y values? It has to concentrate. Then from there, if it wants to move to here, what is the X and value? It has to concentrate. From there, it should move. It should find a path, and using that path, the robot has to move. That is a simple thing. In a say this is the surface, land surface. Okay, robot is moving. Okay, how it will move? Say if it is in this position and it has to go to this position, how it will move? From here, it will check the next cell value, and move. Then it will check, go left because the empty place is there. Then it will go like this. So from here, it will move like this to here. So it uses the X and Y coordinates while moving. It uses the X and Y coordinates while moving. So is okay. So then if the robot wants to move from this place to the from this place to the this place, first you need to find what is this place. What is this place? So how do you find every grid is has to be stored in the digital form only, right? In the in the system, you have to store it in the X and Y coordinates only, right? How any X and Y coordinates can be stored, how anything can be stored using the list of list, right? Using the grid concept. So here you can see this is a grid concept where every values stored in terms of X and Y values, right? So here, say, let me show you some Y0 row. I want to store y0 row is equal to brackets. So say this is the y0 row, right? So in the y0 row, in the complete in this row, how what are those there? 0 0, because there is a obstacles are there. This we consider in terms of the 1 1, because there is no obstacles are there. So when no there is no obstacle, it is considered as 1. When there is an obstacle, we consider it as 0. When it is the colored means it is obstacle is there. No color means it is 1. That's how we are checking and we are writing, right? So how do we write? So if you want to create a row for this, okay, so how we'll do? 0 comma 0 comma 1 comma 1 comma 1 comma 1. So this is y0 row, right? So like this. If I want to go with the y1 row, so where is y1 row? This is y1 row. So can you tell me? 0 1 0 1 0 0 0. So that I can say with the new row. So what is there? First value is 1, first value is 1, second value is 0, third value is 1, and all these are zeros. 1 comma 0 comma 1 comma 0 0 0. This is y1 row, right? 1 0 1 0 0, right? So if like that, say have created a y2, y3, and y, right? So that is the data for all rows. That is the data for all these 1 0 1 2 3 4 5 rows, right? So if I combine them into the grid, how I'll combine? I'll create a list of lists. So how do I create? So grid for these two rows, I'll create the first row, zeroth row, and second row, one row, right? I'm again closing this list. So what it is, grid is having now, it is having a list with other two lists, which is first one is the zeroth row, second one is the first row, right? So if I want to print some 0 0 values, so it will first one executed, okay? Line 4 is not working, okay, that's no issue, but this print of grid is working, okay? Print of grid is working. So print of grid is working where it is having the list of lists, right? So in the same manner, okay, then here the total grid is generated like this. The total grid is generated like this. Then what we are doing, we are from the starting location, say from the starting location, we want to check whether any obstacle is there or not. For that, what we are doing first, we are defining the is path is clear grid and start x and y and end x and end y. So that we are doing def is underscore path underscore. Okay, in that we are what we are doing, we are taking the grid as input. That means total grid in terms of the list of the list. So where are those list of lists? These are the list of lists. Okay. Then we're also we need to check from the starting location to the ending location. Is there any path or not? So for that we need to take the first starting location of x, start start x, okay, and start y, and also we need to take end x comma end y, okay. So this is the function where we are taking the total 5 variables: total grid, start x, and start y, and end x and end y. Then we are writing a function called, first what we have to check, is it a horizontal check or a vertical check? How do we check horizontal or a vertical check? Here we are not checking anything diagonally. We're only checking the straight lines, right? So either the x value should be same or y value should be same, right? So that's what we are checking here. Here you can see, if from here, if you're going here, the x values are same. From here, if you're going here, y values are same. This is 40 to 43. So y, not 40 to 43, 04 to 34. 04 to 34. That means y values are same. If you're going vertically, means what? 20 to 22. That means x values are same. So first what we're doing, we're checking the start x and end x first. Okay. If it is, then what it is means the vertical part. Then we need to check from minimum y to maximum of y. So how do you find the minimum of y values and maximum of y value using the functions min and max function? From that, you have to move from zero location to the minimum location to the maximum location by increasing the positions. Okay. So here, if start x is equal to end x, so when it happens? So if our requirement is from here, you're going to this position. So what is the x value and uh, x values and y values here? Starting positions are start is, okay, say start is x is 2, y is 0. 2 comma 0. This is the starting position, right? So what is the end position? End is, starting is 2, ending is 2. That is x is 2 and x is equal to x value is 2 and y value is 2. So 2 comma 2, right? So say from here you want to check the here. Then first we will check that what is it start x is equal to end x. What is the start x? This 2 is the start x and this 2 is the end x. Both are equal. Then what it will go? Then it will go to find the minimum of these y values. What are the y values? 0 comma 2 are the y values. In that, what is the minimum? 0 is the minimum. From there, what is the maximum? 2 is the maximum. From there, what is the range? So what we are writing here? Here we are writing minimum of y values to maximum y values plus 1. So what is the minimum of y value is, minimum y value is 0, comma, maximum of y value is 2 plus 1. If we are finding the range of that, what we'll get? We will get 0, 1, 2, right? We'll get the 0, 1, 2. This results into the list of 0, comma 1, comma 2, right? So that's what we are writing here. For y in range of minimum of start y and end y. Okay. Then what we'll do for each y, okay, we'll check whether obstacle is x value will be the same, but y value will be changing. We have to check whether it is any obstacle is there or not. If there is an obstacle, we have to write false. Okay. So if grid of y, comma start x or end x, both are, because both are same, right? Is equal to 0. 0 means obstacle is there. So first y value will be here in our example, y value will be the 0, x value will be 2. So we'll check any obstacle is there or not. Then again we'll go, what is the range you'll give? Next, in the loop continues. If it is not there, then loop continues and y value will be having 1. 1 comma 2, no obstacle. Then 2 comma 2, no obstacle. Then it will say that no obstacle is there. Otherwise, it will say that obstacle is there. So that's what we are writing in this, because time is up. If 0 is there, obstacle is there. If there is no 0, no obstacle. We'll execute that. If at all someone is not understanding that, we'll write. So if you are understanding these things, then basic things, common things, then we can go with the writing the bigger codes. First, basic things we have to understand. So at your home, try this. So if x is not equal, then it will check for the y. Then we'll be increasing the x and we'll check for the obstacle. Okay. So like that, we'll check the obstacle. First, we'll try. This is, if start x and end xy are same, this is the vertical path. If start y and end y are same, this is the horizontal path. So if the horizontal path is there, then we'll be horizontal path is there, then we'll be increasing the x value. If vertical path there, we will be increasing the y value, and we'll check the values like 0 or 1. If it is 0, obstacle is there. If there is no 0, 1 is there, there is no issue. It will continue the loop. Then it will return. Otherwise, it will return that there is no obstacle in this. If it is returning true, what it means? There is no obstacle. If it is returning the false, there is a obstacle. Okay, then we'll give the what is called this data. Okay, grid values we are giving. So this is the function we wrote. So which will tell either true or false. If it is false, some obstacle is there. If there is true, no obstacle is there. Okay. So then we are giving the grid. Okay. Then after giving the grid, we will check by giving the values. We'll try to execute this. Somewhere I missed something. Where did I miss anything? Obstacle. Try to come with execution. Try executing this, and in the next class we'll continue. We'll check for the errors, because I need some more time to complete this explaining. So I have given you a link in the chat. Okay, please copy that. That is having the total presentation of the functions. Okay, and take that, and please try the examples, industry examples which we have given. Okay, there is any indentation, maybe because of the code is correct, indentation issues may be there. If the indentation is, if you're having any indentation, that you check, and try to solve those indentation issues and execute it. Okay, so expected in cell number 7 only. So I've given the total PPT. Please try on your own. Okay, and so this is the actual requirement. Okay, so construct the plastering, which can, because of the more human power is they're wasting more human power. uh, Human power is not available. uh, so they want to create a robot which we can do the plastering on the grounds. Okay, ground plastering and vertical wall plastering, that is the requirement. Okay, so for that they have given the brief presentation. In the next session, we'll be discussing that brief presentation, which is given to me. Just I'll show that. So this is so in the videos we have seen, right? So this blasting of the walls in the construction, that we want to that our client or company combinedly want to develop a model where AA will be building the things. AA will be doing the plastings. Okay, even brick building also it wants to do. Okay, so mainly the use case is interior plastering and straight run brick block walls, openings and lintels and all. Okay, so that's what we need to discuss. Here they have given the complete software controls how we can do, and what is the HMI and operation modes, platting workflow, okay, quality and control, safety and KPIs, and what as in data ML people, what we have to do, what we have to design, even in the robot as a robotic persons, what we have to do, okay, that also they have mentioned, okay. Um, so all these things will be working. So we'll parallelly we'll be doing while learning as we spent a lot of time to find the grid path, find the obstacle in the grid path, right? Normally a function can be easily explained, but we are trying to map those functions with the